Yeah, my phone as well.
Start, madam.
One and all present here. On behalf of RMK Group of Institutions, we belonging to Science and Humanity Department of R.M.D. Engineering College is hosting the 12th generic talk series on ADAS, Advanced Driver Assistance System, a milestone towards autonomous car. The topic is aligned to Sustainable Development Goal 9, Industry Innovation and Infrastructure. ADAS technology improves road safety, reduces accidents, and enhances driving comfort by assisting drivers with critical tasks, minimizing human errors, and promoting safer and more efficient transportation in increasingly complex driving environment. This generic talk series will explore the dynamics on the ADAS. Now I would call upon our respected HOD of the department, Dr. V. Tamil Shelvi, to deliver the welcome address.
Thank you, madam. A very warm and pleasant good morning to one and all present here. On behalf of our management, principal, and staff members of our organization, it's my great pleasure to welcome you all for the generic talk series 12 on the topic ADAS, Advanced Driver Assistance System, a milestone towards autonomous cars. I would like to extend a warm welcome to our chief guest, Mrs. Vijayalakshmi Ranganathan, a renowned expertise in autonomous cars, who is the line and test manager, Qualcomm, Gothenburg, Sweden. She has achieved great success in her field and has significantly contributed to the community and society. Our management, our magnanimous management, committed to providing our students not only the academic learning, but also the opportunity to learn from and interact with successful professionals in various fields. Our management is playing a key role for the upgradation of student skills. Today's topic is concerned with Sustainable Development Goal 9. Sustainable Development Goal 9 is to transform about the industry, innovation, and infrastructure. Its aim is to build a resilient infrastructure to promote the sustainable industrialization and foster innovation. The creativity is nothing but thinking of new things. Innovation is doing that new things. If you are not afraid of doing things differently, surely, students, you can achieve the great innovation. So, once again, thank you for the chief guest for taking the time to be with us in this morning. And we are eagerly waiting for you, madam, to hear your insights and experience on ADAS. I encourage every one of us to actively listen to this session. Thank you.
Thank you, ma'am. Now I would like to call upon Dr. K.S. Radha to do the honors of introducing the chief guest to our students.
Good morning to one and all present here. I deem it an honor and privilege to introduce the guest speaker of the day, Ms. Vijayalakshmi Ranganathan, line manager, test manager, and product owner for verification, Qualcomm, Gothenburg, Sweden. She has completed her bachelor's degree in computer science and master's degree in computer applications from University of Madras. Her areas of expertise are software testing, test management. She has got 7+ years of experience in software test management and line management within automotive industry. She has got 8+ years of experience in test management experience in the field of mobile telecommunication, and 1+ years of experience in web page development using PHP and MySQL. In the present job, she is responsible for creating organizational test policy, and organizational test strategy for the new and legacy projects, coordination of test management activities, test planning for vehicle motion components, electric propulsion control systems, battery management systems, and brake controls, and advanced driver assistance system ADAS components. She is also responsible for coordination of testing activities globally in Germany, US, China, Romania, and Sweden. Let me highlight her skill sets here. In telecom technologies, she is an expertise in mobile network technologies such as GSM, GPRS, UMTS, LTE, etc. In automotive, she is well versed in ADAS, functional safety, SOTIF, that is safety of the intended functionality. She is an expert in development and project management tools such as JIRA, Confluence, System Weaver, Codebeamer, etc. She is also a recipient of number of awards. A few to be mentioned here. She has received Star Performer Award for stabilizing the feature testing in 3G networks. She has received NSN Performance Award for excellent contribution to future testing. And she is ISTQB certified tester foundation level. She is a certified SAFE Scrum Master. Prior to current position in Qualcomm, she started her career in Nokia Siemens Networks, Bangalore, as a software engineer in quality assurance. After 3 years, she shifted to Cisco Systems Bangalore and software engineering testing to lead, manage, and drive QA teams in agile methodology and release management activities. Later, she joined as a QA developer in Jobel AS, Norway, ensuring quality of the H5P e-learning products and in the development of automated testing. Before coming to Qualcomm, she was serving as a lead engineer, test and verification software controls in NEVS, Trollhättan, Sweden. Such an eminent and versatile personality is amidst us today. She is going to deliver a talk on Advanced Driver System Assistance Systems, ADAS, a milestone towards autonomous cars. Her talk today will highlight on the significance of ADAS technology in improving vehicle safety and automation, representing a critical advancement towards completely autonomous driving. It gives me immense pleasure to welcome her to deliver her talk. We are honored by your presence, ma'am. Thank you, ma'am. Thank you, one and all.
Should I start? Do you hear me?
Yes, ma'am. We are able to hear.
Okay. Good. Good morning, everyone, and thank you for the detailed introduction. As mentioned, my name is Vijayalakshmi Ranganathan, and I'm currently working and residing in Sweden and focusing right now on the automotive industry in the ADAS domain. And I thank you, R.M.D. College principal and faculty members for providing me this opportunity to share about this domain. And yeah, special thanks to Dr. Priya Ramakrishnan, who reached out to me and explained about this opportunity. Okay. Warm good morning, and I will start sharing my screen. And yes. Yes.
Yeah, it
Hope
is visible.
you are able to see my screen.
Yes, ma'am. Yes, ma'am.
Okay. Yes. So as mentioned several times earlier, the topic is about advanced driver assistance system is nothing but ADAS, which is a milestone towards autonomous car. So what is self-driving cars or what is autonomous car? So a car that can drive by itself without the human driver. So you call it as autonomous car, self-driver car, driverless, self-driving cars or driverless cars or robot taxi. So if in general, if a human driver is driving the car, so he needs eyes to look at the environment and monitor the situation. and then he uses his brain to process the information and decide accordingly. This is the set of action he or she will be doing during the complete driving. So whereas the self-driving cars, it's going to do all these activities by itself without the help of the human driver. How it's going to do? So that is with the help of the sensors. So different sensors which acts as a height, like camera and radar, which perceives the environment, and also with the AI algorithms, this is going to process the information and it's going to decide whether should I drive or brake or steer. So this is what basically the self-driving cars is about. So to qualify a fully autonomous vehicle, a vehicle must be able to navigate without any human intervention to any destination which has never been adapted for use. So it should be able to go anywhere without any human support. That's the driverless car. Okay, why do we need driverless car uh, when you have human driver? Okay, the main reason is it enhances the road safety. As there are a lot of accidents happening, it's mainly because of a distracted driver. So he's not paying attention to the road, he's distracted, or he or she who is driving is very tired, and it's basically the impaired driving causes a lot of accidents, which because of which the lives are, you're losing lives. So with the help of driverless car, with the help of the self-driving cars, you are able to save lives. So the main goal is the safety here. So which reduces the reduction in traffic incidents. So thereby you can save lives. So what else it can do other than saving lives and other than the safety aspect? Yes, it can save the energy and you can drive efficiently, because the vehicles can communicate each other, and then the vehicle knows when to stop, when to brake, and then when to accelerate or decelerate. So by doing this efficiently, you are saving the fuel and the energy, and also reduces the traffic congestion. So by understanding your environment, so the vehicle adjusts the vehicle speed accordingly, and then adjusts to the traffic congestion. So this helps the congestion to be reduced. And of course, and the efficient use of road space, it's basically is nothing but that it can drive closer to each other without, so you could save the space between the two vehicles. So it's basically the efficient use of road space. So the main reason is the road safety, and it also does the other functionalities. Okay, what is ADAS? So as I mentioned earlier, it's about self-driving cars. ADAS is nothing but a driver assistant technology which helps the driver to operate the vehicle safely. So it can help reduce the number of accidents by making the driver more aware of potential dangers around them and providing the timely intervention to prevent an accident. For example, the ADAS system will be constantly monitoring the situation and then informs or warns the driver to act to the situation accordingly. When it means the ADAS system intervenes in the sense it can also decelerate or accelerate, steer, or brake. So it depends on the situation. The ADAS system will do this function if the driver didn't react on time. This is basically helping the driving safety. It's increasing the driving safety by reducing the human error, as mentioned earlier as well. So to reduce accidents, avoiding and saving lives, it's basically what advanced driver assistance system does. And automation. What is automation? Automation is the application of technology, programs, or processes to achieve the outcome without or with minimal input of an human. So this picture, it talks about different levels of automation to achieve the fully autonomous vehicle. So as you see here in the blue color, these are the tasks of the driver, and the cyan blue or a greenish blue, it's the tasks of the vehicle. What does this different levels indicate? So currently the cars, some of the cars on the road has no support from this driver assistance system. That means the driver or the person who is driving the car has to do everything. So he has to look at the environment and then take the decision accordingly, whether it's to steer or brake or accelerate or decelerate. You do not get any support. And you see here from this picture, so the driver has to brake, steer, look at the environment all the time. So the automation means some of these activities, you want this to be automated so the vehicle does it for you, thus by reducing the tasks of the driver. So in the level 0 vehicle, there are a lot of vehicles already on the road where you do not get any support at all from this system, ADAS system. And there's something called level 1, where you will get at least one support from the vehicle. So for example, that a cruise control. So but still, in this case, the cruise control, in this case, the driver doesn't need to accelerate if cruise control is enabled. So he's free from, pressing the accelerator pedal, but he still needs to actively put the hands all the time in the steering wheel and monitor the environment or situation. So here, this is called supported. I mean, that means you're getting some support from this system, and that's the level 1. Here you could see this is the feet is removed. And there's something called partial automation, which is level 2, where you get more than one support. So here, in this case, in the previous case, it's basically the longitudinal support. The cruise control is about the longitudinal direction. But in the level 2, you get both lateral and longitudinal movement, but in a certain situation, not in all situations. Only in certain situation, you will get support from this system in both longitudinal and in lateral directions. So here, the driver observes everything. So you see here, the driver can take the hands off from the wheel for certain situation, that's more important, and also remove the legs from the accelerator pedal, but he constantly monitor the environment. So we say this is a partial automated because not everything is fully automated yet. So here you see here hands are removed. Then next comes the level 3. Here you have the conditional automation. Almost most situation or many situations, you get this longitudinal and lateral support of these features. And sometimes the driver is expected to take the fallback, act as a fallback. So the system, you see the red mark, it alerts the driver to take the fallback. Until then, he or she who is driving can be can be a bit relaxed. So you can take the legs from the paddle, hands off the steering wheel, and can lose little focus. But you need to be, when the vehicle asks you or alert you, you need to take control over. And this is the conditional automation. It works in most of the situation. And you see also this automation level keeps increasing when you're reaching different levels. And in the level 4, it works fully autonomous, but in only certain destination, you can say. So if you want to travel from A to B, then it can be fully autonomous. So the The system doesn't expect the driver to do anything. He can sit, relax, even sleep, but it only works in certain situation. Like if you want to go from A to B or B to C, the defined route, it will do that. So, but this is what you call it also a robot taxi. So it can drive you without the help of a human driver. So this is a very high automation. It doesn't expect the driver to take over as a fallback. And the last, yeah, you can see the differences in this picture. And the last one is the self-driving car, where you just know you don't even have a steering wheel or you don't even have any pedals. So it is completely or fully autonomous. The vehicle does all the tasks. This is the full automation. Let's go to the next slide, which is basically explaining the similar levels, which I explained earlier, 0 to 6. I just want to highlight what features that it support from level 0 to level 5. So SAE levels is nothing but Society of Automotive Engineers. They come up with the standards to define these automation levels, starting from level 0, where no driving or no driving, or no, and then to level 5 is full driving automation. This is, as you see here, the one highlighted in the blue in the first line, it's like the you are driving. That means the human is expected to drive. You get the support from these features, but the human is expected to drive and fully responsible. So if it will help you or assist you, but the fallback, it always comes to the driver, and the driver is responsible for accelerate, steer, and brake. But whereas from level 3 to level 5, the system drive it for you. But in level 3, sometimes, as I showed in the previous picture, you might need to take over. And what features are these? What features are we talking about? There are some examples, but that is what we are going to look in more detail, what these features is going to help in different levels. So as you see here, this is more like warning features, or some vehicles even you do not see them. But in Europe, some of these are mandatory as part of the safety regulation. So that's where you get this emergency support. But it's not always the case in all countries. So, but you can take this as an example. So some warning, you get some warning from the vehicle. So it's more like a momentarily assistance from the vehicle. And here you can refer to a cruise control as an example, or adaptive cruise control as an example. Here you have adaptive cruise control, at the same time you are also centering, the lane centering features works. And then here you have the traffic jam assist, and then this is more like a robotless taxi. As I explained, you want to go from A to B, everything autonomous, and then this is fully autonomous. Yes, this is the different levels that you need to keep in mind. This will be helpful for the upcoming slides. I will talk about more about these features, basically on the level 2 features, or until level 2 features, during this presentation. Okay, as I said earlier, in the beginning, the human driver has eyes and brain to process the information, eyes to look and brain to process the information, so that he or she who is driving takes the right decision. But if you expect the car to do, so you need to fit this with a sensor. So sensor are the one, it's going to perceive the environment. So it's going to more like act as your eyes, observe the surroundings, and provide this information to the ADAS ECU, where it does the decision and control. Okay, so there are different sensors in the vehicle setup. I mean, this is like fully, for example, if you're talking about the level 3 car, then you need this complete set of sensors to support the level 3. So depends on which level the vehicle is, you need those type of sensors. So it doesn't need all the sensors to support a particular level. So it depends. Okay, so let's talk about what these sensors do and how it works. So camera is basically, how does it work? The light enters an enclosed box through a converging or a convex lens, and an image is recorded on a light sensitive in medium. And radar, it uses the radio waves technology to determine the distance between the object or the target that they hit. Okay, so it sends the radio waves. And the LiDAR is nothing but light detection and ranging. It is a method for determining the ranges by targeting an object, or it could be a surface, with the laser, and measuring the time for the reflected light to return to the receiver. So these are the different type of sensors. So you have camera, you have radar, you have LiDAR, you have ultrasonic sensors. So you have different types of sensors. Okay, as you see in the different color here, so the long range radar, which is like the gray one. So the radar, as I said earlier, it uses the radio waves to detect the objects in the front, right? And you see the field of view, it's quite narrow compared to a camera, but the range is it can see, or it can detect the objects until 250 meters. And you take about let's take the camera. It's a wider field of view, but the range is around 80 meters. So each sensor will have its unique functions and its unique capabilities. So you use this camera here, the one in the, let's talk about the camera. The one in the blue, it's in the front, it's the front camera. And you also have something in the side and the back. This you call it as a side camera, or and this one you call it as a rear camera. Usually camera also broadly referred as vision. So you say vision and camera refers to the same. And you also have some ultrasonic sensor. This is for parking support. When you are parking the car, so the driver will not be able to see the completely behind the car. So you have sensors that are set up behind this in the back of the car, that will see the environment and that will help the driver during the parking situations. And you have something called this yellow color one. It's the medium range radar or the short range radar. It's basically the radar with you see from here it has like 20 meter the range. And what it does is the blind spot detection. What is blind spot detection? I will come a little bit detail about blind spot detection later in the slide. But if this is the car you're driving, and if you see another car that's impossible for the driver with his field of vision to notice something coming from this direction. It could be a car, it could be an object. So that is why if some object is near who is going parallel to this car, or if the driver on this lane wants to come to this lane, then there is a possible collision might happen. So this is called blind spot. There's some object here that it's difficult or impossible for the driver to find it. So this is how these sensors are set up for supporting different features of ADAS. Okay, it's basically the similar example of the similar setup, but I'm not going to take long time to explain this slide because I explained earlier, but you can see what features are using what sensor. So it is basically a combination of this sensor. In general, it's used, but some features can be fully rely on a camera-based system. So if you want AV or AB is an autonomous emergency braking. It's one of the features. Then it is completely, you can design it with the help of a vision or a camera-based system, or you could take inputs from both the camera and radar, and then you fuse them and take the inputs. So these are some of the features as you see here. The one in the purple is the radar. So it is for emergency braking. It is basically for the collision avoidance feature, and it also used for the cruise control. And the camera, it's basically used for lane departure warnings, because camera detects the lane markings on the road much better than the radar does. So it depends on which features, ADAS features you're talking about. So the sensor setup will vary. You could use a combination, or you could use a single sensor setup. It depends on the OEM and talk about the car that we are talking about. And yeah, as I said, it requires only a subset of those sensors, not all the sensors. And level 4 and level 5 makes intensive usage of combining these features. So level 4 and level 5, it's like fully autonomous, right? So you need even more sensors to reach that level. Okay, so the sensor capabilities, and also what is sensor fusion. Maybe let's talk about sensor fusion first. So what is sensor fusion? So sensor fusion is the cars are equipped with these different sensors, right? And everything will provide some information. Okay, what does the camera does? Let's say. So you have these type of information, which highlighted. I hope let me use this laser pointer so you know what I'm talking about. Yes. So you see here, sorry, I didn't do that earlier. See, these are the things that you get it from the sensor. Maybe we can look at few example what you get from the sensor. So sensors provide object detection. What is object? So what is object means? Object could be something on the road. It could be a car. A car is an object. A truck is an object. A van is an object. An animal is an object. Or a pedestrian is an object. A bicyclist is an object. So there are several different objects that you could see on the road, and the camera or the radar will, you see here, will detect those objects. So that's why it's called object detection. And in this table, you could see the strength of each different sensor and the weakness of this. So for example, during a snowy weather condition, it's snowing heavily and your car is loaded with snow, then your camera will not be able to see the environment very well. So that's you look at the weather condition, the weakness of the camera. It's because the camera is a weakness because it's not able to see during the snowy condition, whereas the radar can do. So that's the strength. So in an adverse weather condition, a radar will work very good. Sorry, I was referring here. Radar will work very good, whereas the camera has its own weakness. So what it does is basically it does the object detection. It identify which weather conditions, also lighting condition, because you will drive the car irrespective of any time of the day. So if the camera may not work so good in the night conditions, but whereas the radar works. So different lighting conditions, so daytime, nighttime, twilight, so or the evening, so different light condition. And also dirt is something similar like adverse weather conditions. So if your camera is filled with dirt, then the camera cannot see. So that's again a weakness. And you will get a velocity. You need a vehicle velocity that you get it from the radar. So these are the different capabilities of the sensor, which you get it from them. And sensor fusion is it combines the inputs because each has its own capabilities, right? So you need to fuse them. So you need to get the right input to decide accordingly. If I am a person who is driving the car, I know, okay, it's snowing, then I drive accordingly because I'm seeing and processing. But in this case, the car has to do everything, right? So it needs to process that information. If it's the camera-based system, then doing snow weather condition, the camera cannot see the environment properly, then it cannot be able to take the decisions accordingly. So that's why we use fusion based system, that you will fuse the inputs of the different sensor and get an object list. So then you get inputs from radar, you get input from camera, you get inputs from lidar, and then it says, okay, this is the object, and that object is a car. Then you take that object and you process it, and then you decide whether you want to steer or brake. So it's basically what sensor fusion does, bringing them together. Let me go to the next slide. Yes, I hope you see this very well, which is basically what I explained earlier. So it's basically the two different picture explaining the same functionality. So here you have different sensors. You see camera, you have radar, you have, and lidar or ultrasonic sensor, which is for parking, everything looking at the environment and the surroundings and providing data to the sensor to process. This is the processing, because it provides the raw data. How you see, whatever you see from this sensor, it's called raw data because it's not processed. So you need to process this information. And what this processing, after you process, then it will say, okay, camera say, I found a car. I found a pedestrian. And the radar say, yes, it's a car. I found it's a pedestrian. Then all this information from different sensors fed into this sensor fusion module, which process those inputs and provides an input back to the ADAS algorithm or ADAS applications. So the features like collision avoidance features or cruise control or receiving the inputs from the sensor fusion, and they will decide, okay, should I brake now? Should I steer? And should I accelerate? So basically, it's a braking and steering is the decision. This is called actuation. And at the time of, so you will, this ADAS ECU or the applications here will provide the inputs to the actuation system, asking them to actuate accordingly based on whatever the inputs or the signals it has been provided here. And at the same time, it will also inform the driver, because these are the driver assistance technology we are talking about. So the drive, because it's helping the driver or assisting the driver, so the driver will get some kind of a warning. The warning could be a visual warning, so you see some symbol in the dashboard, or it could be like a audio warning. You get like beep 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 beep, some kind of a alert. Or you could also see a text alert with the text. I mean, that is what in the visualization in the display or the, in the cluster, display cluster, the driver will see. So basically, to summarize, you get the cameras will look at the surrounding environment, understand the data, capture the raw data, and the sensor fusion process the data, and it feed into the different ADAS features or algorithms that process that information and decides, and then it tries to actuate. And that actuation could be fed back into steering system or brake system or the battery system or different system that you see here. Depends on what the input you get it from this. This is how it works. Okay, next one. Okay, now we talk about safety. So as I said earlier, advanced ADAS is mainly assisting for enhanced road safety. Okay, when it comes to safety, there are two aspects to it. One is something called passive safety, and one is something called active safety. The passive safety will come into place once the accident has happened. So when the accident has happened, how much of the impact that you are getting from the accident, these passive safety features will reduces the injury. It doesn't prevent the accident. Okay, it reduces the injury after the accident is occurs, after you had an impact. Whereas the active safety features, it prevents from the accidents. It prevents the accidents from happening because it's constantly monitoring and warning the driver, or sometimes it's even taking over the control. So there's basically two different set of safety system you need. The car manufacturers or the OEM here will design both of them because these are mandatory, because sometimes collisions are unavoidable. And that time, when you happen to have a collision, you want to reduce the impact, right? So that's why there are some of the examples of the passive safety features. And active safety features, we talk more about it, little bit more detail. I have some video also explaining how this features works. Okay, let's go to the next one. So, as I said, passive safety features, it doesn't prevent accident, but it reduces the impact. So how it does? What is some examples? So you see here the three things. I mean, I take three things as an example. One is the seat belt. The seat belt, that's why it's wearing seat belt is mandatory, because it helps the driver to position in the vehicle, correctly positioned in the vehicle, because when the vehicle comes to a sudden stop or met with an accident, there are a lot of possibilities for the driver or the other occupants to be ejected out of the seat. That is dangerous, because if you're ejected out of the seat, you go and hit yourself anywhere, and that's not good. So these are the seat belts, which is basically a restraint system that keep the passenger positioned, correctly positioned during an accident. Okay. And there's something called airbag. What is airbag does? So let's think about when there is no airbag, then you go and hit another car. What is going to happen? The person who is sitting in the front or back, it's going to hit in the front. So what you have in the front is the hard surface. You're going to hit your head in the steering wheels, and that causes injury to you, to your head or anywhere. So that's why these airbags are deployed. Again, airbags are something that are inflated and to protect the passengers. So it's basically more like a cushion. So do you want to hit your head with a hard surface like steering wheel, or you get the help from the airbag? So these airbags, seat belts, these are the basic passive safety features for any OEM or car manufacturer must have. So that's why it's very highly important to wear the seat belts all the time to protect yourself in case of the collision. Okay, and this is, as I said, it's the secondary safety feature. It's not the primary, because primary is the one which is preventing the accident. So let's see the primary safety feature. That is the active safety feature. It's the or active safety system, you can call it. There are some examples of active safety system, but one such, I will come to this example, but you understand from the previous slide what I was saying. It's basically these are the active safety system which works the same way as mentioned. It constantly monitors the environment and alert the driver, warn the driver in case of a potential collision situation. Or if the driver doesn't react after warning, it even controls the vehicle. So that's why it avoids or mitigate an accident before it happens. So what are some of the examples of active safety features? Let's talk about few, and we can more detail about AV and LDW later. So ABS. ABS is anti-lock braking system. It helps to prevent the wheels of the vehicle from locking while you are braking heavily. When you press the brake very heavy, then it prevents the wheels by being locked. And it also helps the driver to keep the steering. When the wheels are suddenly, if you do not have this feature and the wheels are suddenly get jammed, then you will not able to steer away, then it leads to collision. So that's more important to have this ABS. This is by default that you have these ABS and ESC in the serial production cars that you see in the market. I'm basically referring to the European market. I'm sure that you have these features in Indian market too, at least these two. And electronic stability control, it's prevent the vehicle from skidding. So it is basically helps the driver from losing the control while turning a corner. So let's assume a snowy road, and then there is a lot of possibility to skid. So it applies the brake automatically and wherever needed, and helps to steer in a right direction. And of course, the emergency braking AEB, as mentioned several times. So when there is a forward collision, doesn't matter forward or a backward collision, the vehicle about to collide with an object in front or an object in reverse, and the driver didn't react on time, then these emergency systems will warn the driver or even apply the brakes to prevent a collision, be it in the backside. For example, if you're reversing and you didn't see something like someone behind, and you didn't react, the driver didn't see or driver didn't react, about to collide, the system will brake for you. And this is about AB. And LDW. What is LDW? LDW means lane departure warning. So you're driving in your own lane, and you're tired and you're driving. At some time, you're trying to drift from your lane to another lane. Then what will happen? If there is some car coming from the next lane, there are chances of colliding. So these features will try to not let you drift away to the other lane. It will try to put you to your lane. Of course, this is main thing. If you do not do this, if you do this without an indicator, if you do it without an indicator, then the system knows that you're intentionally going to the other lane. If you do it without the indicator, then the system thinks that you are drifting away and help you to steer away. That means it steers away automatically and put you back in your lane. So these are some of the examples of active safety features. And I will talk more about these two features a bit more in detail. And yes, AB. So as I said, example, if there is an object in front or in a back. In this example, you see there is an object in front. That object is a car, and that could be a stationary car. That means it's not moving, it's stationary. And you see a stationary car in the middle of the road, and you are driving, and suddenly you see a stationary car, and you are going in a speed like 50 to 60 kph, and you see that, and the driver didn't react on time. Maybe the driver is distracted looking somewhere, or he didn't, he got panicked, didn't react. Then the system will warn you, hey, there is something on the road, react. And the driver didn't further react, then it will apply soft brakes. That's the stage 2. And then as you still see, there is a possible extremely high danger of collision. The vehicle senses that, and the no reaction from the driver, then the vehicle will apply the brakes to avoid the collision. So danger of collision, warning, high danger of collision, soft brake or a minor brake, and extremely high danger of collision, then it will put a hard brake to avoid the collision. This can happen. I took this example as a car. It can happen to any objects. It could be a truck, it could be a van, it could be a pedestrian, it could be anything, a motorbike. And in this case, I took an example, stationary. You imagine a moving car. A car is moving in your front, and both are like, say, 50 kph. And the car in your front, we can call that as a lead vehicle, and your car as a ego vehicle. So then you understand. So your car, ego vehicle, the one you are driving, and the car in front, you can call it as a target vehicle or a lead vehicle. And that is, brake moving, and suddenly it's slowing down due to some reason. And the following vehicle and your vehicle you're going with 50 speed and the lead vehicle slow down with 30, and then if the driver didn't react, then you are going to collide. So in those situations, the AB system will come into help, it will rescue, and it will apply brakes for you so you don't collide into the moving vehicle. So there are some examples that you could see here. This is the forward collision. As I said, there is a reverse collision also possible, that when you are reversing, there is a pedestrian, then the vehicle will brake for you. And then you're going in your lane, there is an approaching car, that's a head-on collision. And then suddenly this car come to your lane, and then you are facing car like this, then the head-on collision, then the vehicle. So the vehicle will stop for you. So there are many scenarios that the vehicle will brake or warn the driver. In some situation, that is something to note. There are some situation where the AB will not be helped to avoid a collision. In that situation, it will reduce the speed of the vehicle. For example, you are going in a very high speed, like 80, and you couldn't stop, you couldn't brake, but due to the distance, but that means you're going to collide the vehicle in front. But AB is going to help you by reducing the speed, so you don't collide at the 80 kph, you collide maybe at a 60 kph. So it will reduce the speed, so the impact of the collision is less. So it will try to avoid a collision, but there are some situations where the collision is unavoidable, then it reduces the impact of the collision. That's the AB does. Okay. And let's go to the next one. I take a small break in talking, and I'm going to play this video. Which video, as I said, you can do, the AB can stop for any objects. In this example, I'm going to talk about the pedestrian. So it could be an adult pedestrian and a child pedestrian who is crossing the road here, and the car is coming from 20 to 60 kph speed, and the pedestrian is walking and suddenly crossing the road, and then the car is going to come and collide into the pedestrian. This is very much happen in the real time, that the pedestrian crosses the car and collide into the pedestrian. A lot of accidents happening. So how do we prevent them? And in some another example you see in the same video, there are parked cars. You see here, there are parked cars onto the right, and you're driving here, and suddenly a child running in front of your car. You may not have enough time to react, so you are going to collide into the vehicle. So how AB system comes to rescue in this situation? Okay, let's look at the video. I take a 2 minutes pause. And I think I need to disable the pointer so I could play. Yes. Okay, let's see. Yeah, I hope you understood the video. It's very hard to see from the video who is braking because you cannot see if the person who is driving the car is braking or the systems are braking. In this case, the foot is removed from the pedal, brake pedal, and the AD systems is braking. And these are, I need to rush up because I see the time is ticking, but these tests we do, it's not in the regular roads because these are safety emergency systems that you cannot, or the safety critical system that you cannot test it in a public road because it's not a mature enough software, right? Because when you develop the software, we always go to a safe test track like this, and then where we test this before we put this car into the market. So there are a lot of tests on, and I quickly talk about it in the upcoming slides. Okay, and LDW, I'll be quicker here. So the car is, sorry. What is LDW or the lane support features? It's basically supports the driver when he is drifting from the ego lane. The lane in which is driving, it's the ego lane, and the lane, the vehicle is called the ego vehicle. So here you see here the driver is driving and you have this solid lane, and this is the dash lane. These are the lane markers that you see in the road. So when the driver is driving and then he tries to drift away to the left or to the right, to the solid line or to the dashed line, then you will get a warning, and the driver didn't react, then you get the steering support from the car, and that's called the lane keep assist. And then the warning, which I said earlier, lane departure warning is, as the name suggests, the lane departure. So when you're drifting from your lane to other, you get a warning, and then you get a intervention, steering intervention. Blind spot monitoring, which I said earlier in the beginning of the slide. So your car is going in this direction, and then the driver's field of view is obstructed. So he will not be able to, or he or she will not be able to see the cars here. That's why it's called, or any object, need not be a car, or anything here. So when he or she is overtaking, then this car can collide into your car. So the sensors here will help you indicate the driver wants, hey, there is an object on your left, or hey, there is an object on your right. So then the driver will be aware and will not overtake. And then with the help of the instructions from the blind spot monitoring system. And I'm going to put this video, I'm looking at the time, I'm not going to play this video. It's basically what I explained. When you're drifting away, then the system will steer your vehicle back to the lane. I can share this presentation later, you can look at it offline. Yes. So far we talk about the active safety features, which is autonomous emergency braking, lane support system, ABS and ESC. And there are some other features which are mainly the active safety features, which were mainly focusing on the safety of the vehicle occupants and the road users. There are other ADAS features, which is, we call it also AD features, call it also at comfort features, which is mainly help the driver in certain scenarios. So what does comfort features mean? So example, if you are driving for 2 hours in an highway, you have almost a defined speed, let's say 80 to 100. And if you need to constantly drive in highway for two hours, let's assume, then you will be very tired to constantly press the accelerator pedal. That time, adaptive cruise control will come into come to your help. So you set a speed. So you set a speed, let's say 100 kph, and then the system will drive and will also maintain a safe distance of the look by looking at the lead vehicle. For example, you're driving at 100 and the lead vehicle is driving at 80. Then what will happen? You're going to collide. So the adaptive cruise control always works on the set speed, but it also adjusts the speeds based on the lead vehicle speed. So if the lead vehicle is 80, then the set speed from 100 will be adjusted to 80, and then it will continue to accelerate in the same speed. And when the lead vehicles increases the speed to 100, then the set speed can be increased to the 100 kph, for example. So that's the adaptive cruise control. And something called highway assist. What is highway assist? It's one of the most advanced features of ADAS, which combines the adaptive cruise control and also lane centering. Okay, you understood what a cruise control is. And what is lane centering? Lane centering is nothing but they put your vehicle in the center of the lane so you do not drift away. So in case of long drivings, especially on highways, the driver gets fatigued because he gets tired from the driving. So these two features combined together help the driver to put the vehicle on the road with the set speed, and this will adjust to the speed based on the lead vehicle. So this will work only in the highways, which is with a certain higher speed. The same way, you have something called traffic assist, which works in a lower speed in a city traffic. So these are basically comfort features which helps the driver in different driving scenarios, but of course considering the safety in place. Okay, so V model. What is V model? So how these systems are developed basically. So these are the software systems. So it is developed. So we uses the V model as an to develop our software. So on the left side, I will not go more into detail, but I will give brief intro on this. So on the left side of the V, it talks about the requirements on the specifications, whereas the right side of the V talks about the testing or the integration and the testing. So you receive the requirements from a very high level. We call it as a customer requirements, and then you break down the requirements into vehicle level, then a system level, and then a software level. So you break down the requirements into these many levels, and then you start developing or writing the single piece of code from the software requirements, and then you test the code with the help of unit testing, and then you do a module testing, and then you combine different modules, and then you do a software integration, and then the complete software, we call it as a component testing. And then you flash the software into a hardware, and where you do a software hardware integration. And once the hardware software is integrated on an ADAS ECU, that is tested together with the sensors, and that is integrated to a vehicle. Vehicle here is nothing but a car, and then you test the complete functionality. So there are different levels because you do lot of rigorous testing on different levels, starting from the low until the high. So when I mean the high level is the vehicle is where the features are going to be realized. That is where the end user, we are going to see how this features being utilized. So you test the features on a very high level in a vehicle, on a very low level in a single in a unit testing. Unit testing is nothing but a more like Google test, for example. So that is the developer who writes the test to verify the code. So this is basically the V model that we uses to develop the softwares or develop the ADAS features, for example. You could be use it for any software development, be it any domain, but this is an example. And so verification, so testing plays a major role because you're testing the safety critical system. If you do not do proper testing, you're putting this untested or unsafe system on the road. So ADAS systems are supposed to provide more safety. So if you provide an unsafe system, then the purpose or the goal or the ambition didn't match. So you need this test the system rigorously or thoroughly in all the levels before you put the cars on the road. So there is something called verification and validation. So verification is nothing but, if, from the previous image you see on the left side of the V, where you have written different requirements. So you verify the requirements that you have written to check, hey, am I building the correct product? Is this what I want to do? Is this works according to the requirements? But there's something called validation. Are we building the right product? Are we building the product right? So the are we building the product right is nothing but verifying your requirements. And then you write test cases. Am I building the right products? It's nothing but validation. So these are the two different types of, you can call different techniques, verification and validation techniques. So several different test levels are being tested under these two different categories for ADAS system, or be it ADAS or any system. And there's something also, it's not just testing that we do. We also have something in Europe, or not just in Europe, in any country, you have something called regulations, you have something called grading, you have something called standards. So what is regulation? Regulation is the regulatory authority who approve these vehicles to be put on the road. So these are, we have in Europe called General Safety Regulation, GSR. So GSR regulates, for example, now, not now, like few years back, they have regulated AEB to be a mandatory feature, to be supported in these vehicles. For one example, so the regulatory authorities decides the safety aspects towards, because their aim also, or their main aim is to reduce the number of traffic accidents and prevent and then the injuries on our roads. They want to make the roads safer, and they also want to save the lives. So we do have a lot of tests, we call it as homologation test, to adhere to the regulations. GSR is one such example. In India also we have the safety regulations that every OEM or car manufacturer needs to adhere to. And we have something called ratings. Okay, I think this is something interesting. It's more like they will provide your car with a rating 1 to 5, and this is called new car assessment program. They assess your car based on certain inputs, and then they provide ratings. And we have some insurances that these companies will have some requirements. There are some examples, IAHS, CIAC, they have some requirements that we need to fulfill too. And we have certain standards. For example, FUSA, we call it FUSA, is basically functional safety. When particular the safety system malfunction, how do you address? So it's basically talks about that one. So every car OEM or the manufacturer who needs also the person or the company who developed the ADAS system needs to take these into consideration about the different requirements from regulation and ratings and standards in order to put the car in the production, or in the serial production, or put the car into the market. Okay, I will not go to in detail. Euro NCAP is such one authority here in Europe, where they assess the car based on the safety aspect. So safety, as I said earlier, passive safety and active safety, and they provide you the ratings. No, red zero means very, very minimal what you get it from the safety regulation, and 5-star is the best car that you could get when it comes to safety. So who are buying the car, even in India and Europe, keep an eye on it. What is the rating this car when it comes to safety perspective? Because after all, we all need to care about safety, right? So that is something more important. So in India, we have something called Bharat NCAP, who does this. So it's not the same entity. They have the similar, and that's called Bharat NCAP. You can look into it. They have this type of ratings. Okay, I will not go into detail. As I said, passive safety and active safety, and what are the things that these Euro NCAP ratings, how they decide when to give 4 rating, 5 rating, 0 rating, whatever, based on these aspects. And I have put the link here to for you to if you want to know more about it. In India, to my knowledge, we are not so much, this is still evolving. Safety assist means active safety features are not part of the NCAP. They are focusing the passive safety, but it's evolving. Soon you will have safety features also in the Bharat NCAP. Okay, so there are some examples. So I researched, I haven't worked with the Indian market, so I'm not so familiar about the cars in India and the ADAS level, but I researched it online and I found this. So there are a lot of cars in India who has already these ADAS system implemented. The max you could find from this list is 1, 2, and 3. But of course, you still have level 0 cars. So I could be wrong, but check the market and check the levels, what type of levels and that we have in the Indian market. So by look on the right side, there are some images that you could see that these are the cars that are available in Europe and US market. So this is the level 2, level 3, and you have this in both US and Europe market. And this is level 4. It's more like a robot taxi, both of them. It's currently these, as I said earlier, level 4 works in only particular locations A to B. So it's currently in US, different parts of US. They are used as robot taxi. Okay, last 2 more slides. The challenges I would see. Okay, we talk so much positive things about ADAS, why we need to have ADAS. It saves a lot of lives and stuff. Okay, what is the challenges that we have in ADAS? So the limitations is there are some sensor limitations. Okay, sometimes based on the sensor limitations, the ADAS system, the accuracy and it's a bit inconsistency because it has limitations on the sensor, it has limitation on the AI algorithms, it has limitation on the GPS. So there are many limitations that could cause this system to be inaccurate and inconsistent. But having said that, these are developing and evolving. And sometimes understanding these features are a bit complicated, or misunderstanding is more common, and the drivers tend to be more reliant on these features. They didn't understand that very well and expect the car to do everything, but that's not the case. As you see, until the level 3, even most of the time the car expects a fallback, or in level 2, until level 2 the driver is responsible. So understanding how this feature works, it's more important to prevent accidents. So being over reliant on the system, it's not going to help, because it's going to it's because it's a distracted, it's more like distracted driving, and again causing more accidents. That's not our goal here. And it's a high maintenance cost, and then the drivers, they needs to learn. Sometimes it might be overwhelming for drivers who are not well versed with this system. So it could be overwhelming, considering the drivers in India or in all over the world. Not everyone will know how to use this. So it's there are some technical challenges in ADAS. And especially when it comes to India, what are the technical challenges? It might work very well in Europe and US in the few years, but in India, how long it's going to take and what challenges we have. Because we have a diverse road condition, because the roads are not good, the roads quality is not good, it's uneven, sometimes missing road signs, and the traffic behavior, most important things, people drive on in different directions. It's hard for this AI algorithm to understand the traffic behavior. So there are some limitations. So it's work ongoing, but these are still open challenge. The infrastructure deficiency, so that is like, for example, GPS mapping, that is not there in all the digital mapping of all locations. Still ongoing, and the connectivity problem, because you need a proper internet connectivity and also fast and reliable connectivity. And the cost of this car, it's very high cost to buy this car with these features, and also high maintenance and something happens. And yes, we need these regulatory and standards more important, because you're doing a safety critical systems, developing a safety critical system. So you need to test this and standardize this system before you put the systems in the market, because you're aiming at the road safety and trying to save lives. So this needs to be, this regulatory authority in India already working on it, evolving, but still we have some challenges here. As I said, the last one, the consumer awareness and acceptance. That's the case everywhere. So they need to understand the features, how it works. They need to accept this. So this is going to happen in the upcoming years, but currently these are the current challenges, or some of the current challenges, I could say. Yes, having said that, I'm ending the talk. I hope this is useful, so you get a good idea about what is ADAS, what is self-driving, and what features that we have, and what cost that is in the market, who does it. Yes, so next time when you buy a car, think about the safety, think about the right rating. I think that's going to help you when you buying this car. And if you want to uh, focus your career in this direction, yes, this is a one good opportunity, or one area that you can focus on, especially aiming at the students, the engineering students. Yes, thank you.
Thank you, ma'am. A wonderful talk. 360-degree view you have given us, ma'am. We were new to this topic, ADS, ADAS, but you have given full 360-degree angle, full complete angle you have given us. I'm very thankful to you, ma'am. We have some questions in the chat, ma'am. I have dropped in the chat. Can you answer that, ma'am?
Yes, yes. Should I?
Shall I read for you?
No, I
Yeah.
can read. Yes, 1 second.
Yes, ma'am.
Talks about the software. Yes, it's heavily depends on software development, what programming languages and skills you would recommend. So I could say C++ or Python. It's one of the, I mean, there are many, but the areas that I have come across, that we are mainly using C++ and Python for this type of development. So I would recommend the kids, the students to learn about this. Development is one area, so testing is another area. So you have different area, right? As I said, or may not be. So you have different levels in the software development. So you're going to design. First, you have to analyze, design, develop, implement, develop and implement, test and release. So there are many areas the students could focus on. So it need not be the development alone, the testing or design. So different areas needs different skills. I just explained about C++ and Python for the development, and for testing, you could you can learn about this ISTQB. How do you test? And they explains the different test levels in more detail. I'm not sure if this part of your curriculum already, but that is another area, because testing the safety critical. I'm going to talk about testing because I have the background. So these are a safety critical system that's very utmost important. So you need to test them rigorously. So you're putting a safe product in the market. If something happens, then you're talking about the lives, the cost of the lives here. So testing plays a rigorous role. There are a lot of opportunities in the areas of testing. There are different levels, as I said. So there is something that the kids could focus. Okay, so the second question, yeah, it's kind of connected to that. So again, this area is quite vast, because here the ADAS development also relies on sensors. The sensors, like that developing a camera and the processor and the sensor fusion. See, there are different areas you could you could find internship, or you want to specialize your skill. I put everything on a very generic level, but it's all quite vast areas. If the camera needs to process and tell and say, hey, this is an object, like this is a car, then lot of processing, the AI algorithms and the CEN networks goes into place. So this is some of the areas that kids could, specialize. So and I could think, yeah, I think, sorry, it says something. I would say different, looking at different sensor side, or the ADAS ECU development, or the feature development itself, the application development. So those are the different areas that kids could focus on. And yes, how do we contribute to the development of ADAS technology in the future? I'm not sure what you mean by how do we, means who, how can we, who are we referring as we? We are talking about the college here, right?
Yeah, college
Yeah.
students.
Yeah, I mean, I would recommend, like here in our company, we do have a lot of internship we provide to the students, and then we work with the universities to develop such algorithms, like the AI algorithm, or difference on what one for, or what purpose. For example, we have vision development. Vision development is the camera development, and we also have the application development. Here I'm talking about the development of AB and lane support features, or the comfort features. So depends on which area. So we are working with the universities and hiring students as internship for some challenging areas within these parts which I explained. So, I mean, there could be a lot of companies in India who is doing that. So I think it's good that colleges could tie up with the companies, would be a starting point, I would say.
Okay, ma'am.
Okay. Is there something?
Sorry, ma'am. Shall we close, ma'am?
Yes.
Shall
Yeah,
I
I
give
see.
vote of thanks?
I see there is a question from Radha.
Three questions only there in the chat.
Yeah, the
We have
last question.
one more. Yes, ma'am. One more is there.
Yeah, I think I've
In
answered
forensic country.
Yeah,
Yes.
this year then with the challenges in India, challenges
Right.
of adapt technology in India. And before that, I was asking this question. I got an answer for that.
Okay. Yeah.
Thank you, ma'am.
Okay.
We need to train our algorithms to understand the traffic behavior more better, so you do not have these limitations. Currently we have these limitations that it may not work very well compared to European countries or US countries, where the traffic are very well organized. So but that's not the case back home, right? So yes, but yes, this is work ongoing. So as I said, we already have cars in India with this ADAS implemented. So it's evolving. The AI going to, the more you put these cars in the road, the car is going to learn every day and improve on its own. So it's going to be an ongoing process, I would say.
Thank you, ma'am.
Thank you, madam.
Yes, ma'am. Now it's time to do the honor. First and foremost, I would like to express our deepest gratitude to our esteemed chief guest, Ms. Vijayalakshmi Ranganathan, for taking the time to share their invaluable insights and expertise. Your enlightening talk has provided us with a deeper understanding of the transformative potential of ADAS in shaping the future of transportation and road safety. We truly honored to have you with us today, ma'am. A special thanks to our respected principal, Dr. N. Anbuchelian, and our beloved chairman, revered vice chairman, and the management team for their unwavering support and for providing us with this wonderful platform to organize such enriching events. Your encouragement and vision enable us to continue pursuing excellence in learning and innovation. To our dedicated faculty members, thank you for your constant guidance and efforts in organizing this session. Finally, I would like to extend my gratitude to all the students for your enthusiastic participation, your curiosity and engagement make events like these truly meaningful. Once again, thank you all for being a part of this enriching experience. Let us continue to embrace innovation and contribution to a safer, smarter world with technologies like ADAS. Thank you.
Thank you, madam.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you. Thank you so much. We'll keep in touch with ma'am.
Yes.
Stop recording.
I will
Thank you.
leave the call now. Thank you.
Yeah. Thank you, ma'am.
Thank you. Thank you.